Hi, Sylvia. Hi, Christina. Hi, Brittany. Hi, Ella. Okay. Good Friday. No, that was last Friday, wasn't it? It's still a good Friday. Okay. Let's see here. Christina. So, Sylvia, let me ask you a question. I went ahead and approved your schedule. Did you get completely registered?
Yeah.
Okay, good. All right. Everything looks fine. So I guess everybody's registered now, maybe, if we're lucky. Got 2 more people in the waiting room. Feel like a doctor. Okay, let's see. I have to do group consultations here. Okay. 1, 2, 3, 4, 5, 6, 7. I got 7 out of 10. That's pretty good. I think I got everybody in. Allison's in. Jessica's in. Haley's in. Unfortunately, I can't see all pictures. This is weird. I can't see Christina, Brittany, Jessica, or Haley. I don't know if you're in on a phone or if you're in on or if your video is not working. But we'll see. Okay. All right. While I'm waiting for people, guys, let me go ahead and share my screen here. And see what we got. Okay, not iTunes. Why does my iTunes always come up when I'm looking at this? Probably some kind of weird underlying, what do you really want to do? Lay around and listen to music instead of do this, possibly. Okay. So guys, while we're waiting for everybody else to come in, let me first apologize for that error on the sheet last night. It was on the first 2 problems where there should have been a Y, where you had a constant. On the 2 easiest problems on the whole thing, and I know I created some, oh God, what's going on here? And I really apologize about that. I don't know what I was thinking. What I was trying to do in typing them out, that's my big problem, in typing them out on the assignment sheet, was to make sure everybody was looking at the same problem, since we have multiple books. When that happened the first semester, I thought, oh, this is always going to be a real pain in the butt. Now it's turned out to be a nightmare. Okay, so one thing I'm going to do today is give you your next homework that's due, and it's not due until next Wednesday. I'm going to write it down right here, and I've already written it down in this, and so I don't have to type it. And again, given numbers of problems hasn't worked out real well, because at least 2 people, well, several people have edition 11, and another person has a European edition that I think is a paperback. So anyway, okay, there's one more person. Get somebody else in here. It's Tara. Okay. We're going to pick up where we left off yesterday and finish it up, and then do a little class exercise that's going to help you to do these problems. This practice guessing is what I call it. So before I start, does anybody have any questions? I know you were probably focused on the last section, but remember all the stuff that I will try to get that homework back pretty quickly, because this next section, of course, depends on getting the right complementary solution. So I'll see if I can get that back pretty quickly, and then you can start working on this next homework. Okay, so questions, anybody? Any general concerns? Are we doing okay? Are we doing okay not only in here, but in general? Everybody okay? People have so many, we did a little survey, and you guys probably filled it out, about how students were feeling about this whole experience. And a lot of it, I think, had to do with you know, you're not set up to study at your house, probably. I mean, particularly if you have younger siblings who are at home, running around trying to get educated somehow themselves. So I don't know if that's the case with any of you guys, but you have my total sympathy if that's the case. But I know this is harder. This is way harder than just being in class. I think it is anyway. And then we had a lot of comments about, well, it looks like the professor's giving more homework than they normally would. I don't know why anybody would do that. I think they were saying because they think the students have lots more time. It's a different kind of time, in my opinion. So I don't know. I'm actively trying not to do that. Although I can't avoid it a whole lot. And sometimes in these differential equations problems because they're long and they're messy. But that being said, I'm trying to believe it or not, I'm trying to go a little slower and trying to sort of pace myself according to me and what you guys can do. Okay. The day to choose whether you do a grade or pass no credit is next Tuesday. I think it's the 20th. So I think it's the 20th. I don't know if that's Tuesday or not. But anyway, keep an eye on that. And if you have a question of me about, I think we've discussed it in this class, but if you have a question from me about what you think you might want to do, then please just email me and I'll try to get back to you as soon as I can. Thank you to the people who were telling me something was wrong last night, because all of a sudden I opened my computer and there were things popping up. I had Brittany, I had Haley, I had Ella. Everybody's like, well, I was looking at it, I was like, oh no. Okay, they're right. They're absolutely right. There should be a Y in there. So if you happen to turn your homework in before you got that announcement, those two problems, as I said, were the easiest problems. It won't take you very long. Just send me a corrected, just put Math210 homework correction and understand it's my correction, okay? And send me the solution and I'll take care of it, okay? Okay, questions, anybody? Okay. Okay, let's see if we can pick up where we left off yesterday. What we were doing was looking at these non-homogeneous linear DEs, where what we had to do was write a general solution. And that general solution always consisted of a YC, okay, plus a YP. And this method of undetermined coefficients that we're doing is a way to find the YP. We already know how to find the YC from the last stuff we were doing, okay? So I stopped with a rule that we had run into what I called a kind of glitch yesterday, where we said you cannot have any overlap in your guess and your complementary solution. Because if you have any overlap there, then that piece that is also a part of the complementary solution is going to wipe out because it is a part of the complementary solution. So you have to bump it up to a degree is sort of what we looked at to get rid of any duplication in your guess, okay? So remember, we call this the method of educated guessing. That's the big thing in it. You have to make sure it doesn't overlap with YC. If there's no overlap, you can just proceed. However, we looked right before the end of class, we looked at a case where we found the YC, we wrote a general solution for the complementary associated part of this. And because the roots were 1 and 1, duplicated roots, or I shouldn't say duplicated there, I'll say roots of multiplicity 2, you're going to get an e to the x and an xe to the x. When we looked at this, our guess was just some constant times e to the x, because when you continually differentiate that, that's what you're going to get, some constant times e to the x. Now, notice here that part of your complementary solution had a constant times e to the x in it. Can't use that one. So what we're going to do is multiply the thing by x. Look at that one. Now, I call these initial guesses, right? When I get to the end, I'll have a final guess. But if you look at ax e to the x, there's that one appearing in your complementary solution again. Can't have that. You've got to bump that power of x up high enough so that you'll be getting some of these things that you need here but they don't duplicate what's in YC. So you end up with an X squared because that's the first thing that doesn't appear here. So the last thing we did in class, it said if any YP contains terms that duplicate terms in YC, then that YP must be multiplied by X to the N, where N is the smallest positive integer that eliminates the duplication. So right here, the smallest positive integer that duplicated, that eliminated the duplication was 2, because I had a power of 1 here, so I need to go up to 2 to get beyond that. So what we'll be doing here, and we got a little exercise to work on here in a minute, is just make an initial guess, compare it to the YC, and see if you need to adjust it to eliminate duplication. Okay. I did have a couple more things I wanted to look at, a couple more examples I wanted to look at, just about guessing here. Let's take a look at this one first. It's y double prime minus 6y prime plus 9y equal this. And by the way, guys, had I not had a y on this one, that 9 would needed to have been over on that side. What I actually gave you without putting a y on that thing yesterday was a non-homogeneous equation. That constant would have been over on the other side. So it was totally, you know, and somebody was dead on when they said, did you want us to use the section we're working on now? And I'm like, no, that's not what I intended. So that's why I was all wrong. I should, leaving out that y was made a big difference. So if you look at, I'll tell you what the YC is here. You look, it's m squared minus 6m plus 9. If you look at the characteristic equation, m squared minus 6m plus 9, you'll see that that thing right there will factor into m minus 3 times m minus 3, which means I've got a repeated root of 3. Which means the first piece of this is going to be c1 e to the 3x. The next piece is going to be x e to the 3x. Okay. So now we're going to look at the other side. And we're going to make, again, what I call my initial guess. And I'm going to make that by looking at the structure of this thing right here. So if you first look at the 6x squared plus 2, you say, oh, that's a quadratic. So I will put ax squared plus bx plus c in there. Here is a constant times e to the 3x. Okay. So if I look at, did I write that properly? Something looks funny here. Oh, here, I know. That was my final guess. Let me tell you what my initial guess was. Sorry, I put a final guess up there. All right, so my initial guess, if I look at just this, I look at right there, my initial guess would have been that ax squared plus bx plus c, and then I would have had a d times e to the 3x, okay? That's my initial guess based on that, okay? Now, if I compare that initial guess right there to this thing right here, it's already got it's got constant times e to the 3x. Okay, so what I'll do is I'll bump that up 1 and I'll put dx e to the 3x. So I'll change that. I'll make another a sort of amended guess, x e to the 3x. But then when I look back at the YC again, I'm like, uh-oh, I've got an x to the 3x there. So I need to finalize that to avoid duplication with this one right here. So that final YP right there is this thing. The x squared is there, so I can avoid the duplication of e to the 3x and x e to the 3x. Okay, I didn't leave myself enough room to write there. Okay, so question anybody about what I'm doing. That looks a lot like the last one that we did in class the other day. All right, let's look at the next one.
That one needs to change.
Say that again, Haley.
The DE to 3x. That needs to change because it's a part of the YC, correct?
Yeah, the reason, see it right here on the side, on the right hand side, that's my g of x. And when I make my initial guess, I say, well, that's a constant d times e to the 3x. But when I look back at YC, I've already got a constant times e to the 3x. Okay.
What about this do you not have to do another, like an x squared?
Exactly. So what I'm going to do next is say, well, what if I multiply it by x? And I have dx e to the 3x. I look back over there and I'm like, that's not going to cut it either because I have an x e to the 3x. So the next place I'm going to go is to an x squared. That's the first place I see where I don't have any duplication. So this is the one, this right here is the one I'm going to use. Because as I stepped up those powers of x, I had duplication twice. I have to go as far as I need to avoid that duplication.
Sorry, my screen cut off that x squared. That's why I was like, well, how are we stopping there? I didn't even see that.
Oh, sorry. Can you see it now?
I got it. It was my fault.
Okay. All right. Anybody else question on why I did that? All right, let's look at the next one. The next one says we got y double prime plus or y triple prime plus y double prime equal e to the x cosine x. Now, essentially, what I've got here is the yc that looks like this. So if I pull out an m squared, I've got repeated roots of 0, and I've got a -1. Let me say one thing about how you write that when you have these 0 roots. You might want to be careful here because you would have that's just a constant. That's just C2 times x, and that is going to be just C3 times e to the -x. Just so you know, when you're looking at this thing, if your guess happened to include a constant, you'd have to put, and you had an a there for your part of your guess, you'd have to put ax. But you know what? Ax won't work, so you'd have to put ax squared. That doesn't happen in this one because I don't have a constant value in there. What this one consists of are just e to the x's times cosine x's. What we know when we differentiate e to the x's times cosine x's is that we just get a bunch of e to the x's times cosine x's back or e to the x's times sines back. So when I make a guess for that, I'm going to say, well, it's some constant a e to the x cosine x plus b e to the x sine x. What you notice with your guess here is that there's no overlap at all between this thing right here, okay? So you need to make sure that you don't have that overlap. If you don't have that overlap, you can proceed. Okay. Let me change this one just a little bit to show you what I'm talking about here, what I just said. If I had in this one, if on the right-hand side, I had 5 plus e to the x cosine x. Now this last part, this guess would have been, this last part right here would have had the same guess. But if I had 5 there, I would have had to add another constant. Since we already used a and b up there, I'd have to suppose it was c, okay? And I look at that as my initial guess on my yp. So that's my initial guess. But and c plus all those other things, that thing up there, all right, this thing right here, all right? This would have been a problem because in your yc is a constant. So you say, well, I've got to multiply it by an x to avoid that. But when you multiply it by an x, you see also here, you see C2 times an x. So you've got duplication at that level. So in order to avoid the duplication here, you would need a cx squared and then plus the other stuff that I had. There was no duplication in that other stuff. But you see what I'm looking at? And you really probably want to get rid of those e to the zeros. It's good to put it there to remind yourself where it came from, because all our roots look like e to the root x, the rx or mx, I'll say, mx. So, but go ahead and write it like this, and then you'll be more likely to see, uh-oh, I've got duplication there. Okay?
Dr. Harrell, can you scroll up the last example before we continue?
Scroll back down, okay.
Okay.
Yeah. All right.
All right, I got it. Thank you.
Okay. Anybody else, any question about those? Like I said, the last thing we're going to do today is go through a sheet. I'm going to let you guys make some guesses, and then we're going to assess how you did on them. Okay. By the way, there is on page 143 a table. This is that sort of tells you what initial guesses ought to look like, depending on what your g of x right here looks like. I don't know if you've gone through this section carefully enough to see that, but there's a table of possible things you can have, like polynomials times e to the x's, or polynomials times cosines, or things like that. So you might want to take a look at that. That'll be a good guide to what your initial guess is, and then you have to adjust it. Okay.
Dr. Harrell.
Yep.
Tiara's in the waiting room.
Oh, I'm sorry. I thought I let her in.
She got kicked out, and then she.
Oh, okay. All right. All right. I'm sorry. I didn't hear it ding at me. Thank you. Thank you for letting me know. I'll make sure I get her in this time. Okay. Let's see if I got her in here. Geez, Haley, what kind of dog is that? That's a big one. Okay, I got Tiara. Tiara, can you hear me?
Yes, ma'am.
Okay, I'm sorry. I didn't see it ding back in for some reason. I don't know.
It's fine.
Okay.
I'm just happy to be here.
Okay. All right. So Tiara, what I was saying was we're gonna do a lot of practice in a minute, making guesses on some of these what the initial YP should be. And I also said you might want to look on page 143. There's a table there of what initial guesses generally look like for these kinds of things. Okay. All right, let's look at a couple more. Let's look at a couple more here. All right, so we've got the fourth derivative of y plus y triple prime equal 1 minus x squared e to the minus x. So note what we've got here, guys. We've got a constant, and we've got this polynomial function times e to the minus x. So here's my initial guess. I need a constant, okay? I will also need some quadratic term right here. That's where x squares might come from. And I'll put bx squared plus cx plus e. So again, if it's a polynomial and it's multiplied by that, I just need a total generic quadratic, and then times the e to the minus x. So I'm going to take that initial guess right there and compare it to the YC that I found. So the first step on this, guys, is find your YC. Find your YC. So if I pull an m cubed out of this, my roots are 0 of multiplicity 3 and minus 1. So that'll be c1 e to the 0x, c2 x e to the 0x, c3 x squared e to the 0x, and then there's the c4 e to the minus 1x for all those roots. This one is just like the thing I showed you a minute ago, okay? So that's going to be c1, that's going to be c2x, that's going to be c3x squared, that's going to be c4 e to the minus x. Now, here's where you really need to be careful in a couple of ways, guys. If you look at your initial guess, you got an A here. That causes duplication with that C1. So I know I'm going to have to put another X in there. But when I put another X in there, it causes duplication with that term. So I'll put another X in there. That'll be X squared. Problem is, it causes duplication with that term. I have to go all the way to X cubed before I can say I don't have duplication. Okay. So is everybody okay with that piece of it? Are you okay with that? You understand what I'm saying by duplication of terms there? All right. If I look at this one, this was a quadratic. My guess was bx squared plus cx plus e. Now, here's where you have to be careful. You're going to be multiplying this e to the minus x into here. So if I look back at my YC right there, and I multiply the e to the minus x times bx squared. Well, I don't have any e to the minus x squares. That one's okay. I don't have any x e to the minus x's there. However, look at this. Right there, I have an e, which is just a constant, e to the minus x. There is duplication right there. So what I have to do is bump that quadratic up by a power. And if I bump it up by a power, that essentially means I'm multiplying the whole thing times an x to get rid of the duplication there. Now, you can't just do it here. You have to do it through the whole quadratic there. You have to do it through the whole leading polynomial, we'll call it. So it'll end up being bx cubed plus cx squared plus ex. And then when you multiply it all out, you don't have duplication anymore. So that thing right there is my final guess.
Okay, 2 questions.
Yes.
So the original A corresponds with the arbitrary constant, or
Yes.
no, with 1, right?
It corresponds with the 1. Yes, exactly.
Okay, bump that up to x cubed because my problem goes up to x squared in my YC.
Yeah, the things in, look at your YC. You got a C1, you got a C2 times X, you got a C3 times X squared. So these are all constants times X squared to avoid duplication there that I thought if those hadn't been there, I wouldn't have a problem. But to avoid duplication, I've got to go all the way up to X cubed. In other words, 1 higher than the one you see.
And that's the same issue with the x squared here. Is that x squared, that C3 x squared?
Yes.
Okay.
Yes, right there.
Thank you.
Okay. So
Do
did you
I
have
need
another?
a constant to the cubic? Like, would it be bx cubed plus cx squared plus ex plus f? Or is that
No,
bad?
no, you don't have to do that. That's actually a good question. But because if you added an F, if you did that all the time, you'd constantly have duplication. You see, you'd have another constant times e to the minus x, and you just want to get it beyond what's originally there, beyond the powers the problems that you see here.
Okay, thank you.
Does everybody see what Haley's saying? Why didn't I put bx cubed plus cx squared plus ex plus f? That would sort of completely undo everything I had done here, because then I'd have f e to the minus x. I'd have duplication again. So don't do that. Okay, don't do that. Okay. Now, guys, I have not been concentrating on carrying these things all the way through. So let's remind ourselves of what we do when we get our final guess. When we get our final guess in this problem, thank God I didn't have to do it. It probably would have taken me 4 pages to do it. I would have to take 4 derivatives of this thing. See, this is my yp. Okay, that's my yp right there. I'd have to take 4 derivatives, then 3 derivatives, plug in all of that stuff, and set the coefficients equal, okay, of all the things that you found. Okay, so that's what we would do in that particular problem. All I'm trying to do right now is get you to make the right guess, and then we can go back and work on the details later.
Do you take the derivative of just the yp or the y?
Just the yp, just the yp, okay? And then when you let me roll back to one that I actually did do Wednesday, and we'll talk about that. So let's see what we did here. Let's go where we first did one. They're all messy, but here's a good one right here. What I did on this was I had one last Wednesday that looked like this. We made a guess on it. This is linear, so my guess is going to be ax plus b there. This is a linear times e to the x, so I'm going to have a cx plus d times e to the x. There's no duplication there. This is sort of before we talked about duplication, guys. But there is no duplication here. Because we had e to the 3x's and e to the minus x's. You might say, oh, well, there's a duplication. There's a constant times e to the 2x. But it's not duplication because these are e to the minus x and e to the 3x. So you got to, it's not only just the coefficient you're looking at, is it the same function you're going to be getting derivatives of. So at that point, what I did was take the yp. I took the derivative of yp. I tried to simplify it as much as I could. I then took yp double prime. I simplified it as much as I could. Simplify it as you go. You will not regret it later. So simplify it as you go. And then what I do is I plug it into the dE. Now the dE was y double prime, so I put in that simplified version right there, that y double prime, minus 2y prime. I put in the y prime from there, right there, and then minus 3 times y. I cranked all of that out, all right, and tried to get it as simple a form as possible. And what I ended up having left, I looked at, you might want to watch this again because I've scribbled it all up when I was working it. You're going to match your coefficients, okay? You're going to say, well, what's the coefficient on this one has to be? Well, the coefficient when we combine these kinds of terms, the e to the 2x terms, we got a minus 3c. That means minus 3c has to be 6. which means C has to be -2. So I know that. So on and so forth. Okay, so that's what you'll need to do there. Okay, so that's just kind of a reminder of what we'll do once we get this guess right. You might want to look at, before you do all of this, you might want to look at that lecture and then sort of the end of this one. All right, let's go back to where we were. Okay, so I've got one more. Yeah, I got one more I want to show you, and then we'll just start doing some practice. This is an initial value problem. So let's talk about how we would do that. And I did look at this. I did this one, okay? I did it all the way through. So the problem was that the second derivative of y plus y is 4x plus 10 sine x. We want to find out what y is. When you find the characteristic equation for that, it has imaginary roots. Remember, please, that when you have imaginary roots, you want to look at the root kind of like this, 0 plus or minus 1i. If you put that in the quadratic formula, or just m squared equal -1, bring it over, take the square root, you get plus or minus I there. When we have an imaginary root, remember its form. It's e to the alpha x, where alpha is the real part of this. So it's e to the 0x. And then the 1 and the -1 get absorbed into this cosine thing. This is what we looked at when we talked about Euler's law, or Euler's rule. It's C1 cosine 1x from that 1 right there. So that's the imaginary part. So that's the coefficient on the x there, plus C2 sine x. Okay. Fairly easy, again, because we know that e to the 0x is just 1. So don't start dragging that through. It's just 1. There's my YC. All right, now on the other side of the equation is a 4x. So that's a linear term there. So my guess to go with that is something generically linear, ax plus b. This is, this has signs in it, but as we know, when we take derivatives of sines or cosines, we get sines or cosines. So I need c cosine x plus e sine x. Finally, I started dropping out d. Remember I said d sort of interferes with other notation, that operator notation. So you won't see them use d. All right, let's look at my final guess. All right, let's compare it to the YC. This ax plus b is okay. I mean, I don't have a constant times x, and I don't have another constant isolated here. However, when I look at this, I've got c cosine x and e cosine x. I have a constant times cosine x here, and I have a constant times sine x. I need to get rid of that duplication. It appears in both of them, and if it appears in one, it'll appear in the other, because your initial guess put the same thing on these. So what I'll do is I'll bump both of those up by an x. So cx cosine x and ex sine x. That means I now have no duplication there. So that was my initial guess. Because I had duplication of these terms in YC, I made a final guess. I adjusted it so I had no duplication. Okay. Is everybody okay with that? All right. The rest
I have a quick question.
Sure.
In the guess,
Yes.
I see that the ax plus b is for the 4x.
Yes.
But the b, why do you need to have the b?
Okay, because if you see an x to the first power, your derivatives, 4x could be a derivative of, here's a reason. If I had 4x plus 3, the derivative of 3 would be 0, and I might have generated a 4x somewhere else. So I actually have to have not only just that x in there, but I have to have just a general, a generic linear. So if you identify something as linear, you're going to always need an ax plus b, because a constant is going to have a derivative of 0, and it would drop down possibly to an ax or whatever you had. It depends. Because for instance, if that's your YP and it appears back in your equation, and you take Y prime, what you're gonna, I mean, if you put Y in there, you'll have this term. And if you take Y prime, you'll just have an A in there. You need both of them, all right? Because that B would disappear the first time I took a derivative down here. But it still needs to be in there because it's part of Y.
Okay.
Okay?
Thank you.
Anybody else? You okay with that? It's just the same, Tara, it's the same as if this had been an X squared right here. I'll erase it in a minute. But if that had been an X squared, I wouldn't have just put in an AX squared. I'd put in AX squared plus BX plus C. I'd put in a general quadratic there. Okay? So be careful with that. You don't just need an AX squared, you need the general quadratic. If it had been an X cubed, I would have had to put a general cubic in there. AX cubed plus BX squared plus CX plus D. Okay? All right. Can I erase that, guys? I'm going to just, so it doesn't confuse what you're looking at later, maybe.
Yeah.
Everybody understand that? Okay. So we put the generic polynomial of degree that the thing that you see. Okay, so the next thing I did was write my general solution. Okay, so this is a little different from the other ones. The other ones we were not asked to find C1 and C2 in the other ones. Now notice that that's what we're being asked to find here, given certain initial conditions. And the initial conditions that I had here were these. And those initial conditions are meant to tell me what C1 and C2 are. All right, what C1 and C2 are. Now, let me say what I did and what I skipped here. When I found the YP, when I went through the whole process of finding what the YP was, I found out that this is what it was. I did not go through those details there, guys. But this is the YC, and this is the YP I found by plugging in my guess. Okay, it ended up that A was 4, B was 0. You don't see a B in there. And there was E ended up being 0, C ended up being -5. So I go through the same process to find my YP. But in the end, if I have initial conditions, what I do is I look at the entire general solution to this non-homogeneous DE.
So
And
when
then, question.
when you take the derivative of the YP, that gives you the constants in the YP, and then
Yeah.
the general solution, you go back and put what we figured out for YP.
Yes. Yeah. See, I would have, guys, I would have taken this one. I skipped things here because I wanted to get to the part about the initial conditions, but I would have done YP prime and YP double prime, and I would have taken those and then plugged it back into this thing right here. That way I could then match the coefficients, find out what A, B, C, and E were. And that's what this thing is right there. You might want to go through and check that. I'm not sure they put the details of that in the book. Look here, guys. Let's see if the details are in there. Yeah, guys, the details are on page 145 of that. Okay, the details for this one, for the part that I skipped here, this part right here is on 145. Does everybody see what I'm saying? I just sort of cut to the chase here to show you what happened when I had initial conditions. I first got to find out what the A, B, C, and E are here. And I do that by the ways I was doing it before. I just find the derivatives, put it into the original, match the coefficients, and what I came up with was this thing right here. Right? And again, what I'll say is that I found out that 4 was A, B was 0, because you don't see it in here. The coefficient on this one was -5, so C was -5. Apparently E was 0 because there's no cosine X term showing up there. Is that clear? I would have written it out, but I think it's in the book if you want to see. Once I do that, no matter what kind of problem it is, I will write the entire solution. The entire solution will be the yc plus yp, which will be c1 cosine x plus c2 sine x, plus the yp, which is that. Now, my point here is that's what I use to find C1 and C2. So here's what I'm going to do with that. I am going to see my conditions. My conditions were y of pi equals 0. That's my first condition. So guys, what I did was just, I can find some things now, because here's y right here. If I plug in pi, I'll have C1 cosine pi plus C2 sine pi plus 4 times pi minus 5 times pi cosine pi. If I go through and figure that out, cosine pi is minus 1, so I get minus C1. Sine of pi is 0, so that one drops out. So that one drops out. This one's minus 1. 4 pi is there. Cosine of pi is minus 1, so minus a minus there will give me plus 5 pi. It turns out then that I have minus C1 plus 4 pi plus 5 pi, which means C1 is 9 pi. So I've got part of what I need. This thing right here is 9 pi. You'll see it in my answer down there. Okay, so 9 pi. Now the other condition, guys, was, I must have been running out of paper here. Yep. My other condition, if you go back to the, let's go back to the problem here. My other condition was y prime of pi equal 2. So I had the other condition, y prime of pi equal 2. Well, in order to use that condition, I, of course, have to find the derivative of y here. So I went through, I found the derivative of y. I then put in pi, because of this condition, there it was right there. Because of this condition, I said, well, if I put pi into the derivative, which is what I did here, simplify as you go, it should equal 2. When I plugged in all the way across, sine of pi is 0, that drops out. Cosine of pi is minus 1, so there's minus C2. Plus 4, sine of pi drops out. Cosine of pi is minus 1, so I get a plus 5 here. So what I end up with is 2 is minus C2 plus 4 plus 5 is 9. C2 equals 7. So to use your initial conditions, 2 things. You have to have the function to use one of them. If it's a second order, it's going to have 2 conditions. And then you have to take the derivative to use the other one. Put them back in on your answer. That was C1. The 7 was the C2. That was C1. The 7 was the C2. And then there was your particular solution right there. Okay. Question, anybody? Okay, that's a lot. I want to practice some on the guessing, but let me say something about the homework that's going to be due on these things. First of all, it's not going to be due until next Wednesday. Okay, I haven't, so it's not on a sheet yet. I will put it on a sheet, but I'm going to cover myself one way or the other here and to make sure I get the right things written out. On this particular assignment, I'm gonna give you odd ones, and the reason for that is that this is so messy, and it can be long, and you can miss signs and so forth. You will have the answers in the back, so you can tell if you got it right. Okay, it's kind of and this is how some things you do in college make an impression on your mind, and you never forget them. When I took differential equations, I was over at Wake Forest. I loved my professor. He was really good, but I was taking the final exam, and I was doing one of these problems, and it was really messy. And I knew I could do it. I just knew I had made a sign error somewhere. And it was making me nuts. And I was the last one in the room. And he was just kind of standing there. And I would say, just give me a few more minutes, give me a few more minutes. And finally he said to me, I've got to go watch the evening news. And I'm like, okay, fine. It's like, I'm done. That's all it took. But you know, everything came out okay. But I don't think I ever got what I should have gotten for that problem. But point being that it's messy. So take your time, be careful. I've assigned 4 of them, so you can make some different kinds of guesses, initial guesses and so forth. One of them is an initial value problem. So you're gonna have to do what we did on that last one. Uh-oh, somebody's bumped out again, I think. That's Allison got bumped out. Okay. All right, hang on to us. Let me make sure I get her back in. Okay. Allison, are you back?
Yes.
Okay, good. Okay. I was talking about what the homework is for next week, okay? So they're all odd. I'm hoping they're the same problems that are in everybody's book. But if they're not, lots of times a book will throw in one problem. It'll put off the sequence of numbers. Because I'm giving you the advantage of having the answers in the back, if in that edition 11 or that paperback edition that somebody's got, that this doesn't look like 5, 15, 21, 35, and it's even, which means you won't have the answer, let me know and I'll give you the answer. Okay, I'll show you what the answer is so you know kind of what you're working towards. Okay, is there a question about that? Anybody? Okay, let's just look at some practice guessing. So I'm done with what I want to do with this particular section, but I want to play around with some guesses here. And let's see if I can find my copy of it. Practice guessing, where'd I put it? Right down here. Okay, so this is something I use every semester, and what I did was take some problems from another book, from this book, and so forth, to find out what some of these guesses need to be. Let's see, look at something else. Okay. Okay. So here's what I want to do with this, guys. And we can do it. You can do it by just looking at this and writing down what you've got. Or I asked you to print it off last night so you could kind of maybe have a copy of it all in one place. But let's just take a look at these things. Here's what I've done on this. I have already solved the characteristic equation for you, okay? So what I want you to do, I've solved the characteristic equation. I want you to write the YC, and then I want you to make an initial, and down here, notice I want you to make an initial guess. And then over here, I want you to put what your final guess is. In other words, if you have to make any adjustments, make them over here. If you don't have to make any adjustments, tell me that one's your final guess. Okay. So let's do this one, guys. I'm gonna give you a few minutes. This one won't take too long, I don't think. Let me just give you a couple minutes. I want you to write the YC, and then I want you to make an initial guess, and then I want you to make a final guess. Okay. What I also want you to do is kind of give me a thumbs up on one of those reaction keys down there when you think you're done. And then maybe I'll be able to see I need to go on. I can go on. So do you guys see where the reaction button is down there across the screen? It may be, it'll say thumbs up or clap or something like that. I don't. Does anybody see it? Should be down there across the thing. Does anybody see that?
I don't.
Okay, I don't see it either for some reason on mine right now. I'm looking under more. Chat, invite. I don't see it. All right. Okay, so let's see what we've got here. Let's see if we can write. Let's see if we can write that first one. That is an imaginary root, which means that alpha is 0 and beta here is 3 halves. Okay, so my YC should be e to the 0x times cosine 3 halves x. All right, cosine 3 halves x plus sine 3 halves x. Okay, is everybody okay on the YC?
Isn't
If
there,
not, what's that?
aren't there like C1 cosine, C2 sine? Like, aren't there still constants?
Yeah. There'll be a C1 and a C2 there, but that's what, and this will be that'll be e to the 0. Of course, did not leave myself enough room for anything, but ultimately it will look like this. YC is C1 cosine 3 halves x plus C2 sine 3 halves x. And that's because that e to the 0 is 1 there. Okay? So actually we'll have a C1 and a C2 in there. Okay, is everybody okay with the complementary rewrite or the complementary solution? Okay. So let's look at my initial YP. My initial YP is going to be based on this thing right here, that 15. And that 15 is just a constant. So what's my initial YP going to look like, guys?
AX.
No, not AX. If it's just a constant, it's going to be what? It's just going to be A. It's just going to be A. All right. So in other words, what you're looking at here is you're going to be differentiating this thing and plugging it in here, and you can get all you ultimately need is A, because the second derivative of A will be 0, and if this is A, I can tell what the solution to this thing is. Y equal 15/9, because if you just get an A here, the AX will be that. So there's your YP. Is there any interference or duplication between your initial guess and your YC? Anybody see any problems with that? I don't see any duplication. So the final YP is going to be A. Tara, you're only going to need an X in it if there was an X in it to begin with, and that way then you'd need an AX plus B. Okay, but all I really need here is an A. Okay, let's look at the next one. Let's see, I'm going to leave some room up there so I can write on that one up here. But write your YC and write it with C1 and C2. You should write it with C1 and C2. And then make an initial guess about what your YP should be. Okay, let's take a look at this one, guys. Because my roots are -3 and 2, that's what my YC is going to be. Here's the thing I'm going to base my YP on, my initial YP. Now, this is a place, speaking to Tiara's question a minute ago, I've got a 2x there. My YP there, guys, what you should be putting there is AX plus B. Okay, AX plus B. And if you look at that, I don't see any duplication between anything in here and these things in here, because these are all constants times this an exponential function. I don't see any duplication there, the types of terms those are. So my final guess will be my YP is AX plus B. So I kind of started out easy there. We didn't have any duplication in any of those. Okay, let's try the next one. Is everybody okay on that one? Tell me if you didn't get it and if you don't understand why it is what I've put. When I do this when I'm in a physical situation in class, I'll have people work on it in pairs. We don't have that benefit here, so. Okay, let's look at the next one. There's the DE. Here are the roots. There's the G of X right there. So write your YC, make a guess, and then see if you have to fix it at all. Okay, I'm kind of trying to see if I see I'm done looks on people's faces. Tiara's got a great silhouette over there because I can see all the sun coming through the window behind her, because I can't see her face, so I can see her head. Okay, so let's look at this one, guys. Now I see you. That's better. All right. So so we got a complex root here. Real part's 2, imaginary part's 4 and -4. That's where the cosine and the sine come from those multiple roots. By the way, roots that are complex roots always come in pairs. They always come in pairs. So that's going to be e to the 2x, c1 cosine 4x plus c2 sine 4x. Everybody okay on the YC? All right, now let's take a look at this thing right here, because that's where we're going to make our initial guess. This is a quadratic, so I need a generic quadratic there, ax squared plus bx plus c. That's at least the first part of that. On this one right here, I have a linear times e to the x. Now, in the initial guess, if it's linear, you do need a whole generic linear one. Remember, we talked a minute ago about not adding an f when we were adding an x to it. But if we have 26x, what's going to go there is a coefficient on e to the x that's going to look like ex plus f e to the x. Ex plus f. And again, I skipped d for the reasons I explained before. Okay, so the question is, do we have to adjust it? But is everybody okay on what that is? Okay, it's because you got this linear term multiplied by an e to the x. So linear times e to the x, and that thing's quadratic. The kinds of terms I have over here, guys, are e to the 2x's times cosine 4x and e to the 2x's times sine 4x. I see none of those here, so I've got no problem with duplication there. That's my final guess. Okay, eventually I'll get to one we have to adjust in a second. Excuse me. I keep telling myself I've got allergies, and I hope that's the case. Since I still can't break 97.2 on my temperature, I'm happy about that. So I'm fine, except I have allergies. Okay, let's look at this thing. All right, everybody, they're the roots. They're real roots. Write out what the YC is, and then write out what your guess is, and see if there are any complications there. Has Haley got allergies too? Okay.
It is really awful. It will stop in about 2 hours after I get up. I'll be fine. But until then, I just keep blowing my nose.
Yep. All right, guys, let's look at this one. This one isn't too bad. There's your YC. We've got these real roots, so it's C1 e to the 3/2 x plus C2 e to the minus 1/2 x. Here, I want to make sure you get this. There's just a cosine over there, but you have to have more than that in your YP, because the derivatives of cosine 2x will also generate sines of 2x. So my initial YP is going to be A cosine 2x plus b sine 2x. I think I did one like that on Tuesday, but I wanted to remind you of that again there, okay? So if you anytime you see a single cosine or a single sine up here in your g of x, you need both of them there in your YP. Now, it's pretty easy to see there's no duplication here because all these are exponential functions, e to the 3/2 x and so forth. So that's also my final guess right there. Okay? Okay, do the next one. Okay, let's look at this one and see what we got. The roots were -2 and 0. So in the end, I wind up with C1 e to the -2x plus C2 for my YC. Using this, I'm going to make an initial guess of the fact that that's linear. So I'm going to put AX plus B there. That's a constant times e to the x. So I'm going to put plus C, or e to the -2x, C e to the -2x. Now, guys, you don't need to lug the sign along, any signs in particular along here. It's just a constant, so you just replace it with C. So don't worry about doing that. Okay, so I now need to compare this with my YC. Is there any duplication right here in your initial YP? Well, you got a constant times e to the -2x there, okay? I need to make an adjustment on that. I cannot have that duplication, or that this is going to come out with you end up with something like 0 = 5 or something, because you don't have a this will get sucked up in your, or this thing will get sucked up in your homogeneous solution. So I'm going to make, when I look at my final YP, at least on that term, I'm going to write CX e to the -2x. That'll avoid the duplication in that one. What about this other thing, this C2 here, and this thing? Is there any duplication between that and that? Mic off, somebody tell me. You see any duplication between that and that?
The constant.
C2.
Yeah, the constant. Look at the B and the C2 are both constants right there. So what I'll do is I'll take this AX plus B and I'll bump it up. I'm multiplying by X, and I'm running out of, hang on, let me make that look better. Let's do this. So by X, and then I'll add it on to the other thing that I had there. Now, when you multiply it by X, you'll have an AX squared and a BX. That reduces, that eliminates the duplication there. Okay, so the final thing, let me write it out better here, will look like AX squared plus BX plus CX e to the -2x. Okay, is everybody okay with that one? So that's the first one we had any duplication in. What you will do with that, remember, is take, this is a second order DE, you'll take your YP, and then you'll do a Y prime, plug it in here, you'll do a Y double prime, plug it in there, and then crank all this out, start to match coefficients over here, and you'll find out what your values of A, B, and C need to be. Okay?
Can we not worry about that constant in the like the plus B takes care of that constant in the 2x plus 5, right? In the
This, oh
Yeah.
yeah, AX plus B. I mean, that's a full linear thing right there, Haley. So yeah, I mean, yeah. I mean, if you wrote AX plus B plus another C, well, the B plus C would just be a constant, so that you just put a 1 there, okay? Or you put 1 AX plus B there. Anybody else on that one? Let's go to the next page. We'll do a couple more, and then what I will do, guys, on this is I will post the whole key on Moodle, okay? So you can look and see if you got the right guesses. I would do this before I started the homework. I mean, you can figure out the homework but you got to have the right guess, and you don't want to go through all the messiness of this without the right guess. So this is critical. All right, do 6. All right, guys, I'm going to look at this one now because I really want to get to the next one and then we'll call it quits. The YP on this one, if you look, the YC is this, it's easy. You got the two real roots. The YP, my initial guess is just going to be A, E to the 4x's. You have duplication right there. So you're going to have to add an additional x to this. So your final guess will be AX e to the 4x. Okay. All right. Take just a minute or two to do 7, and we'll let that be the last one, and then I'll post the rest of it on Moodle for you. Okay, let's take a quick look at it, guys, since we're running out of time here. What you got up here in your g of x is a cubic times sine 2x. Your initial guess is going to be a generic cubic, ax cubed plus bx squared plus cx plus e times sine 2x. It doesn't matter if you start with sine or cosine, plus another coefficient potentially, but it's got to be a cubic of fx cubed plus what comes next? G x squared hx plus I, and that one will be times cosine 2x. Cosine 2x. Okay. So I'm not finished yet because we need to look at if there's any duplication. But is everybody okay on what I wrote for the for that YP? It's because this thing right here is a cubic. I have to have a cubic times sine 2x and a cubic times cosine 2x. Okay. Is there duplication with this and this? If you look at it and you're looking at it in kind of a multiplied out form, guys, you've got an e sine 2x here, and you've got an I cosine 2x there. You definitely have a problem because either the 0x was 1, so you've got a constant times cosine x, there's duplication. You got a constant times sine x, there's duplication when you multiply it out. What I need to do in this one is take this cubic right here and multiply it by x, and the same thing with that cubic. So in the end, it'll end up being ax to the 4th plus bx cubed plus cx squared plus ex times whatever that was, sine 2x plus a, b, c, e, f x to the 4th. G, I'm multiplying this one by this thing right here, this thing right here by an x. So fx to the 4th, gx cubed plus hx squared plus ix. That'll remove the duplication from the one that's precedes the cosine 2x. Okay, guys, run through and do these before you do anything. I'll try to post this on Moodle right now. Actually, my key for that. I may go. Let's see. It's got another little bit of a page in the back of another page. Okay. Anybody got any questions? Okay. So there's no immediate homework due. If you need to send me something of correction because of an error I made on the last homework, just send it to me by tomorrow morning and I'll be able to spend some time on grading. I hope to spend some time on grading tonight. So if you can get it to me by tonight, as I grade them, I send them right off to you. So we'll do that.
Posting the homework, like, are you giving us another assignment sheet? I know-
Yeah, I'll give you another assignment sheet, but let me take the next assignment that's due is the one that I wrote on this one.
Yeah.
So I'll be posting a full assignment sheet, but I'll put those, I won't try to type those things out again on the assignment sheet. I'll just rely on the fact that I gave you guys that other stuff right wherever it was, back on the other sheet, okay? You know what I'm talking about, the 147. That's not due until Wednesday, but I will write that on the assignment sheet, okay? I'm trying to do the assignment sheet a week at a time. It's, I just don't know what decisions I'm gonna make yet about what I need to, what's important to finish out and what's important to go and do something else. So we're gonna do it a week at a time. Anybody else, question?
I have one more question, sorry.
Okay.
If we email you today, can you send us like your records of our grade at this point so we can
Yes.
make a decision about grades?
Yes, I can do that, okay?
And
Go ahead.
if I request a grade now, but something terrible happens, you can turn it back to a
Yes,
pass?
I can,
Oh,
I can turn the clock back on that one, okay? So let's just assume nothing terrible is gonna happen. But
First,
okay.
if I ask for a pass and then I end up making an A, can you put an A in?
Yeah, I think I can do that too.
Teachers are so confusing with this job. They're all taking different stances. So I'm
You know
just trying-
what? Listen, I have been working here for, I'm not even gonna tell you how many years. And I have changed grades. I don't think it's gonna be any different here. I'll tell you what, I'll double check with Richard, with the registrar, with Dean Vinson, and say, look, I still have the power to change a student's decision if it's in their best interests. Okay, and I will check with you about that too. I'm not going to change anything before I check with you about that. So yeah, I mean, if you said you want to pass and you all of a sudden you made an A and you're like, heck, I want that A. Yeah, I can do that too. I think.
Okay, cool.
I mean, I feel I sort of sound like Donald Trump. He's like, I can do anything. I can tell the states what, blah blah blah. But I'm pretty sure I can do that. I'm not really sure he can do what he's saying, but anyway, whatever. No politics. So anybody else? Any questions? All right. I will. I'll see you on Monday. You'll be getting some things from me homework wise, and maybe an assignment sheet ahead of time this weekend. So I will see you on Monday morning.
Do we know when we're gonna have another test?
That's a good question. I think that probably I'm going to do a test. These problems are so long, I really don't want to wait too much longer, but I do want to get a couple more methods in. So let me play out the assignment sheet for next week, and then I'll let you know. Okay?
Okay.
Okay.
Mhm.
Anybody
Thank
else? Question? All right. I will talk to you on Monday. Have a good weekend.
Thank
You
you.
too.
Mhm.